flat surface. A cone is a birthday hat. It tells drivers, watch out! It holds ice cream so it doesn't go splat.
Hey everyone, so yes, here we are with 11.7 on the surface areas and volumes of cones, and you know that I couldn't resist playing that one. It was just so corny, it was funny. Ice cream cone goes splat. So we're going to look at these surface areas and the volumes. We looked at volumes before of the prisms and the pyramids. We're going to look at the volumes of the cones, which is almost exactly the same thing as the pyramid was. We'll see that's pretty much the same formula, in fact. It's the surface areas, though, that is going to be a little bit different and a little more involved. So we start with that here. But before, let's go ahead and just look at a cartoon. Far side, back in the, I guess this would be like the medieval ages. I told you guys to slow down and take it easy. Something like this would happen as they launched one of their friends out into the enemy. I suppose they were supposed to be launching rocks or something like that. Alright, so here we go with looking at the cone. So basically a cone is the shape of a cone. We'll maybe do this in class, but you take a circle, you cut out a sector of that circle, and then you just kind of tape it all together and you can make a cone out of that, and that's what it is. So, but it starts with really a circle, and so the surface of this here is a sector of a circle. That's what it is. It looks like a Pac-Man. And so that's why I wanted to show you that, so that way when we get into trying to figure out what the surface area of this would be, obviously we have a base and we'll have to find the area of the base of that, but then the surface area would be a little bit different. It's the lateral surface of a cone. So here you go on page 346. Look at your vocabulary. Go ahead and write this down for the vocabulary. That at the lateral surface of a cone, it consists of all segments that connect the vertex with the points on the base edge. So if here's our cone here, our base edge is this circle, all of the segments, and that's a lot of segments all the way around. Basically, it's the whole surface of this cone part here. That's what we're talking about with the lateral surface of the cone. So it says here, recall that a circular cone or cone has a circle base and has a vertex that is not in the same plane as the base. So there's your vertex at the top, there's your base down below. The altitude or height, that's the one here in red, going straight down to the middle, is perpendicular, is the perpendicular distance between the vertex and that base. So you can see that's why it's at a right angle right here, perpendicular. So in a right cone, the height meets the base at its center, and the slant height is the distance between the vertex and the point on the base edge. So our slant height would be the height right here along this edge from the vertex to the base edge right here where the radius comes out and touches it. Your height is right down the center, though, kind of like we saw with the pyramids. That's the same idea. But here on this one we have a lateral surface here of this, and that's called a slant height. So our slant height is going along here, this edge. So I wanted to show you how we do this. Now this is very similar to what we've done before with actually 11.1 and 11.2 when we were trying to find the area of a sector, or even the kind of like the arc length around the outside, kind of like a circumference of that arc. So that's kind of similar to what we're going to be doing here. Let me show you what I'm talking about. Okay, so this is kind of how we're going to be able to see how to find this, basically the area here of this sector. We want to know what's the area of this sector. Here's what it looks like. The cone is all now kind of, put out flat. So here's your base of this cone right here. That would be the base. We need to find that area. And then if you take this, whole lateral surface right here and flatten that out, like we would untape it and put it out. Remember, we have our missing sector right here, so we need to find the area of this sector and add it to the area of this base to find this whole surface area. So if you remember from 10.1, we were doing this. We were saying that we could say that the arc length over the circumference of the whole circle is equal to the arc measure over 360 degrees. Remember, we had the part over the whole. So So part of the circle, which is the arc, over the whole circle. And then we talked about in 10.2, very similar, we talked about the area of a sector over the area of the whole circle is equal to the arc measure over 360 again. So if both of these are equal to the same fraction, then both of these fractions here can also be equal to each other. And that's what we see down here. That's why I didn't want to just leap to right here. I want you to remember that these two can be equal to each other. The area of the sector over the area of the whole circle can be equal to the arc length over the circumference of the whole circle. And that's what we see here. Area of the sector over area of circle is equal to arc length over the circumference of the circle. And now if we start just to plug things in and simplify, we'll see how we get down to the formula for this here. I didn't want to just, here's the formula without explaining where we get this formula from. So we have our area of the sector here. Now this here would be considered our slant height. That's the slant height right here. That's your height from the vertex to the base edge, which actually acts as a radius now of this sector. So if we want to think, okay, what's the area of the sector? We're trying to figure that out. We want to figure out the area of the whole circle. The area of this whole circle here is obviously pi r squared, and we're going to use L for r. So it's pi L squared instead, because the L is the radius. And then we have the arc length of this. So the arc length is going to be just right here, 2 pi r, okay, because really the radius is going to be basically the same as this. So the arc length is really the same as the circumference of this whole circle right here, which is 2 pi r. Because remember, if we were to, wrap this around, it's going to wrap around this circle right here. So this length right here is the same as the length around this circle. So the length of the arc is 2 pi r, whereas the circumference of this bigger circle right here would be 2 times pi times the radius of L, so 2 pi L. We can then just multiply both sides by pi L squared. That's what they're doing now. And then just kind of, just simplify this. We could cross cancel our 2 pi's right here. That gets rid of those. We could cross out this L with one of these L's over here, getting rid of that square. And what's left now is pi L and R. So pi R L, those three things are left as the area of the sector. That's just a little formula now to find the area of the sector. So that now takes us to our core concept, which we can see here, which you can see as the S, big S is the surface area now. To find the surface area of this right cone, it is the area of the base, which is pi r L, so pi times radius squared. That's the area of the base, plus the area of the sector, which is going to be pi RL, which is where we just got. So basically we have here is the surface area is the base area plus the area of the sector, which is around here. This is a sector, and that sector really is the lateral surface of the cone. That's what this is here. Okay, so where we have R is your radius, L is the slant height of this cone. All right, so let's go ahead now, using that formula, let's go ahead and try to find some surface areas of the right cone. Okay, so on page 347 in the extra practice, number 1 and 2, it says find the surface area of the right cone. Let's go ahead and you probably have the formula right there from that core concept, but I'm just going to put it up here one more time just so I can see it as we're working through this. So its surface area is the area of the base, pi r squared, plus the lateral surface of the cone, which is pi times r times L. Remember, that's how we got that sector. That's the area of the sector, which is around the outside wrapping this thing. So now remember, this is area, so as we actually get units, we have centimeters on here, we're going to be having units squared because we are talking about area. So this is not going to be volume units cubed. That's for volume, is when you cube the units, but when we do area, that's always units squared. All right, so let's go ahead and try to just plug things in. What do we know? We know the radius is 3. We know the height of this is 4. We know the slant height right here is 5. This is our slant height. The L is 5 on this one. So everything's pretty much given to us. We can just start going ahead and just plugging things in. So it's pi times the radius, which is 3 squared, plus pi times the radius times the slant height, 3 times 5. So this 4 we didn't even use. the actual height of the cone is not a part of the formula for surface area. If we were trying to find the volume of this cone, well, then we would be using the 4 and we would not be using the 5. So now we just simplify things. 3 squared will give us 9. So this will be 9 pi. This will be 15 pi over here. So 9 pi plus 15 pi will give us 24 pi. And then just using the calculator, 24 times the pi button, or 3.14, gives us approximately 75.36 centimeters squared. And remember, this is square units because we're talking about area. Now, number 2, it didn't show us the picture, but it might be helpful to draw a picture for this one. It says a right cone has a diameter of 1.8 inches and a height of 3 inches. So I drew this one out just so we can kind of look at it again. So a little circle with the radius here. Now, radius is half of the diameter, so half of 1.8 is actually 0.9 for radius. That's what we got to use. And it says our height is 3. It tells us the height, this middle number. We don't use that middle number. We need to figure out the slant height. So this time they didn't tell us the slant height, and now we have to find that. But what we do create here, remember what we've created with the height and the radius is a right triangle with the hypotenuse being your slant height. So you have basically your 2 legs of a right triangle here, and your hypotenuse is L. So let's go ahead and use the Pythagorean theorem then to figure out what L is. So that's a squared plus b squared equals c squared. Our L is the c squared. So just plug everything in. That's going to be the one leg here, 0.9 squared, plus 3 squared equals c squared. If you want to put L here, you can. And now we just square each of these. So it's going to be 0.81 plus 9. And that's going to be 9.81 when we add these together. And then we're going to have to take the square root of that. So the square root of 9.81 on the calculator, we can do that. 9.81 square root of that is 3.13. So that is what the L is. L, our slant height, is 3.13. And so now we can go back and use this formula here to find the surface area, where we're going to see pi times radius squared. Our radius is at 0.9. So pi times 0.9 squared plus the pi times radius times the L, the slant height. So it's going to be the 0.9 times the 3.13 number. So pi times 0.9, and I just put times 3 on this one. I probably should have put 3.13. I'm not sure why I didn't on this one, but yeah, so I'm going to have to fix that. So that's going to be different. Maybe I went off of this 3 right here. So that would be a mistake I made earlier when I did this before. And so I was setting this up. So let me fix that. So this is going to be a 3.13. Make sure I'm ready. Yeah, that's fine. Whoops. This is going to be a 1.3 here. There we go. Okay, so now when we're actually working this out, we're going to see this is going to be a 0.81 again. So 0.81 times pi plus, and when I multiply these, let's go ahead and do that on the calculator. I already have that there. Just times my 0.9 now is going to be 2.82. Let's just call it 2.82 pi. And let's add the 0.81 in. So I'm going to say plus 0.81 to that. And now I know how much pi I have. So this is now going to be 3.63 if I round it to the 2 decimal places. And then times pi. And so now we'll find out our actual, it's going to be approximately, if I multiply it times 3.14 now times that equals 11 point, really it would be 11.39 if we go 2 decimal places, 11.39. And this is going to be in inches, so we're talking about inches squared because it's surface area. So there's our answer for this one. All right, let's go on to the next part, which is talking about volume again. So like I said, the volume of a cone is very similar to the volume of the pyramid. We see the same kind of diagram in the last lesson when we were talking about the pyramids, that basically if you took a cylinder and sliced it up into 3 equal parts here and had a cone with the same base and the same height as this cylinder, then you could take it would take 3 conefuls to fill up this cylinder. And so if we know the volume of the cylinder here is going to be base area times height, then we just have to multiply, basically cut it, divide it by 3 to find the volume of the cone. And that's what we're seeing here again. So the volume of the cone is 1/3 times the base area times the height. And remember, for all cones and cylinders, the base area is always going to be a circle, so it's 1/3 times pi r squared times h. And again, another way we could see this is just doing pi r squared, so we could say volume is actually equal to pi r squared times h divided by 3 if we wanted just to do it that way as well. So we can figure out what that, basically the volume of the cylinder would be, divide it by 3, and that would give you the volume of the cone. All right, let's go ahead and try a couple of these then. Okay, so page 348 in the extra practice, finding the volume. Now, if we're talking about volume, we're going to have to use the centimeters now cubed, and you can see this is basically the same figure we saw in number 1. We're just now going to find the volume of it. So we're not going to use the 5 this time. We will use the 4. So remember, the volume of the cone is 1/3 times the base area, which is the pi r squared, times the height. And so we're going to be using the height this time, which is the 4 centimeters. This would be the slant height. We don't use that one for the volume. So you got to be very careful and not get confused between which one of these numbers you're using. So as we plug things in, the volume is going to equal 1/3 times pi r squared. So r again is 3, so it's going to be pi times 3 squared times the height, which is the 4. And so this is going to end up being 9 inside here, or 9 pi, which we can cross cancel with the 1/3 there. So 9 and 3 can cross cancel. So 3 becomes a 1 and 9 becomes 3. And so now we have, this is all just 1 right here, and we really basically have 3 pi times 4. That would give us 12 pi. And so now we just do multiply 12 times pi, 12 times 3.14 on the calculator. We will end up with 37.68 centimeters cubed. And again, don't forget the 3 on your units this time, because we are trying to find the volume. Number 4, again, it doesn't show us this cone, but it might be helpful to actually see the cone. So I'm going to go ahead and draw it again, just what it says here. The radius is 5, and we have a slant height of 13, and I'll label that. So here's our circle, my radius is here, and I just kind of drew a little cone going on top of it, and with a dashed line, there's the height. So we tell the radius is 5 here, our slant height, which is out here, is 13. We don't know the height, and that's the one we do need to know on this one. So again, using Pythagorean theorem, we're going to have to find the height with the Pythagorean theorem. So we could do a squared and b squared, so this would be like our b squared, our leg, is equal to c squared, which is where the 13 is. So 5 squared plus h squared equals 13 squared. That's just using Pythagorean theorem with this right triangle that it created here, because this height is always going to be perpendicular to the radius. So that's going to be 25. 13 squared is 169. We need to subtract 25 from both sides. So 169 minus 25, that's what h squared is going to equal. We'll need to take the square root of both sides. So 169 minus 25 is 144. When we take the square root of both sides, the square root of 144, as we know, is 12. So our height is 12 on this one. And so now, using our formula up here, we can now plug in the radius and the height. And so it's going to be starting off, the volume is equal to 1/3 times the pi r squared. So 5 is our radius, so it'll be 5 squared. Pi times 5 squared times the height of 12. And we know that this is 25, so basically it's 25 pi here. Now we can also cross cancel 3 with 12. 3 goes into 12 4 times, so we could be doing that. Cross the 3 out, make the 12 into a 4, and now 25 pi times 4 is what we have left. That's 100 pi. So when we multiply 100 times 3.14, that would give us an answer of 314 feet cubed. Now it would be an approximate answer. Obviously, we could put a decimal to that more, but approximately to the nearest whole number, it's going to be 314 feet cubed. All right, our joke of the day: what has 4 wheels and flies? A trash truck. Isn't that the truth? So problem 6 and 7 on the extra practice is wanting us to find the indicated measure. So we're not necessarily tasked to find the volume or find the surface area. They're giving us those numbers. We're finding other things, like on number 5 it says find the slant height, and on 6 we're finding the height. So we're still going to use those formulas though. So since we don't see the actual cone here, it might be helpful again to draw a cone just so we can kind of get a picture of it. So I always draw that out, so a little kind of oval for the base here, for the circle base, and then just this little kind of thing going up a cone on top of that. So your slant height would be L. Your radius is 7. That's what it tells us in here. So a right cone has a surface area of 440. So our S is 440. The surface area is that. The radius is 7 inches. So we're trying to find its slant height. So we don't really need to know the height at all because we're looking at the surface area. That's not a part of the surface area formula. So we want to use that surface area formula to help us. So we know that we're going to start with the 440. So surface area does mean 440 equals. And then remember, it's going to be the area, the base area, which is going to be pi r squared from here. So it's going to be our pi times 7 squared. So that's what our base area is. And we're going to add that to the pi times r times L. So pi times the radius times the slant height. And that's where the L is what we're trying to find here, find its slant height. So we don't know that one. So r is 7 again, and we're just going to put an L so that there's our variable. So we're solving for that variable. So as we kind of clean this up over here, we're going to make this 49. So 440 equals 49 pi will be our first one, and this will be plus 7 pi times L. And so we want to, get this term here has the variable, so we need to move this 49 pi to the other side. I'm going to subtract 49 pi now from both sides, so it cancels it here. But when I subtract it from 440, here's where I need to change it now to a decimal. So we'll need to do 49 times 3.14, or times the pi button on your calculator, about 153.86. So that's what we're looking at to subtract. 440 minus that number is going to give us something that equals the 7 pi times L here. So we'll see that 286.14 is that number, 440 minus 153.86. It's equal to 7 pi L. And so now at this point we want to divide by 7 pi to get the L by itself. So when we divide out the 7 pi, they cancel here, but again I'm going to need to change 7 pi to the decimal. So 7 times 3.14, that's going to give me a decimal of 21.98. So that's what we're going to divide by. And when I divide this 286.14 divided by 21.98, that'll give me my answer for the slant height, which is just 13.02. And we're just going to say inches on this for the slant height because it does show us that the radius is inches, so the slant height is going to be inches as well. For number 6, now we're saying a right cone has a volume of 528 cubic meters. So we're looking at the volume formula. That's the 1/3 base area times height. And its diameter is 12 meters. So we'll need to cut that in half for the radius of 6. We're trying to find the h here, the height. So again, if I draw this, might be helpful. So you can see a picture of it. So we can see here's our base area. The radius is 6. We're trying to find this height here, which I drew as a dashed line. So that's what we're looking for. So using our formula, our starting off with volume is equal to 528. So we'll say 528 is equal to 1/3. That's the part of the formula. And then it's going to be the base area, which is really pi times radius squared. So pi times radius squared, which is 6 squared here, times the height, which is our h. So the h is the variable that we're trying to solve for. So we'll clean this up again here. This is going to become 36 pi, which we can then cross cancel with 3 because 3 goes into 36 12 times. So I'm doing that. 528 equals the 1/3. I'm cross canceling 3 and 36, making this now 12. So 1 times 12 is 12 pi times an h. So 528 is equal to 12 pi h. And then we're going to divide both sides by the 12 pi to solve for h. And so when I do that, I'm going to have to again figure out what is 12 pi. So 12 times 3.14. That'll give me what I'm really going to divide by. So 37.68. That's going to be this number now. So 528 divided by this on our calculator will give us our answer for the height, which is 14.01. And since the diameter is in meters, our height's going to also be in meters. All right, moving on to the next one, which we'll see as kind of similar to the other ones that we've seen before, where we're going to look at similar solids and then also a composite solid. That's our next two. So here's an example of just similar solids. It tells us that the solids are similar. Find the volume of cone B. So we're going to use our cone, or our volume formula of the cone. And we're going to do it just like before. We need to find a scale factor. They have corresponding radiuses here. And so we want to use that to find the scale factor. And then remember, the scale factor cubed will always be equal to the ratio of the volume. So that's what we're seeing here. Scale factor would be 3, which is 9 over 3. And we're putting B over A on this one, so it's going to be the volume of B over the volume of A is going to equal the scale factor cubed. And once you can fill that in, you then can just multiply both sides by the 15 pi to figure out what the volume of cone B would be. All right, let's go ahead and try our number. I think it's problem 8 or 7 on this one, or is it 9? So yeah, it is 7 here. I forgot where we were at. So cone A and B are similar, so it doesn't show us the shapes. We don't need to see them. We're just told the information. The radius of cone A is 4 centimeters. The radius of cone B is 10. So there's your corresponding radiuses there. And the volume of cone A is 134 centimeters cubed. We're trying to find the volume of B. So first we need to find the scale factor using the radiuses. So that's going to be, picking one over the other. It really doesn't matter which one you put on top. You can do cone A on top or cone B. I think I did cone B on top. So radius of B over radius of A. That way I had 10 over 4. But I could have done it the other way as well. So either way, you could still get the right answer. So 10 over 4, we'd want to simplify that down to just 5 over 2. So there's our scale factors, 5 over 2. So that now, if we were to cube this, it's going to equal the... So we got to cube our scale factor. It's going to equal the volume of B over the volume of A. So since I am doing B over A, I got to continue with that of B over A. So we know the volume of A. We can plug that in. So 134. And I think here's why I'm doing this. So yeah, you might think, okay, why don't I do cone A on top? Well, the reason is because I know cone A's volume. So it's going to make it easier for me when I get down to here. All I need to do is multiply both sides by cone A's volume. Whereas if it's on top, it makes it a little more challenging to solve the little proportion here or equation. So when I plug everything in, we can plug in 134 down here. We're going to plug in 5 over 2 here for our scale factors. So volume of B over 134 is equal to 5 over 2 cubed. Remember, you're cubing it. That's what it shows here. So we got to do 5 cubed over 2 cubed. 5 to the third power is 125. 2 to the third is 8. So it's going to be the volume of B over that 134 is equal to 125 over 8. And now what I need to do is I can now just multiply both sides by 134, which really means I'm going to cross multiply up to here. So I'm going to basically multiply 134 times the 125. So volume of B is equal to 125 times 134 divided by 8. We can do that on the calculator. 125 times 134, that equals this number divided by 8, gives us 2093.75, and there's our answer. And we're going to say just centimeters cubed again because we found volume. All right, we're going to go on to the composite solid next. So here's one that's a composite solid. Find the volume of the composite solid. Remember, a composite solid just means you have more than one solid shape here. We actually have a cone on the top, as you can see, and a cylinder on the bottom. So we want to find the volume of the cone and then the volume of the cylinder and add those two together. So that's basically what they're doing. So the volume of the solid is going to be the cylinder plus the cone. So once we find that, finding the cylinder, this volume, that's just going to be, again, base area times height. Our height's 5. So pi r squared, which is going to be radius here is 6. So they can see that. So you're going to see pi times radius, which is your base area, times the height, which is 5. That's the volume of the cylinder. And then for the volume of the cone, it's 1/3 times the pi r squared, again right there, times the cone's height. The cone's height is 4. And then you just go ahead and just simplify all that down and figure out how many pi you have. So as you kind of do this here, you can add the pi's together. You end up getting 228 pi, but then if you want to find out actually the decimal number, use the calculator to multiply by pi. Alright, let's go ahead and try our problem number 8. Okay, so our problem is very similar to the other one, just maybe a little more narrower or thinner of a shape here. But we still got a cone on the top and a cylinder on the bottom, so we're still going to find the volume of this composite solid by adding the cylinder's volume plus the cone's volume. So volume is going to equal, for cylinder, base area times height. So now this is going to have the same radius right here. It's 2 inches. That's the same as for both, going to go for both cone and cylinder. So it's going to be pi r squared, and 2 is r. So pi times 2 squared, that's your base area, times the height for the cylinder is 5. So that's going to be our cylinder's volume right here. We're going to add it to the volume of the cone, which would start off with 1/3. So plus 1/3, and then it's going to also be pi r squared, so pi times 2 squared for that one as well. And then we're going to multiply by the height of the cone, which in this case is 4 for the cone. Okay, so now let's start multiplying things out. So this is going to be 4 times 5, which will give us 20 pi for our volume of the cylinder. And then this is going to be 4 times 4, which is 16. So 3 does not go into 16, so really it's going to end up being 16 pi divided by 3, or over 3. So we can think of it like this, 16 pi. So that's the 4 times 4 times pi. And then if we multiply by 1/3, it's just over 3. So now as we kind of add these together, we could get common denominators. I could make this 60 pi over 3 and then add the pi's together. I could do that. So, or we could just figure out the decimals. If we needed to find the actual pi answer, that's what we would have to do. But if we're looking for the decimal answer, then we just can figure out, okay, well 20 pi on the calculator is 62.8. And then this one, I would do this like 16 times 3.14 is 50.24 divided by 3. That would end up giving me 16.75 approximately. So plus 16.75, and then just add those two decimals on the calculator, and that gives me 79.55. And since we're finding volume, again, it's got to be cubic units, so inches cubed. All right, so that concludes 11.7's lesson, and I will see you very soon on our last one on 11.8.